Welcome into the second NAT lab. In this lab, we're going to configure and verify dynamic NAT. Dynamic NAT is a little more complex than the straight-up static NAT that we did in the last lab. It involves access control lists. You remember we talked about ACLs and how they're used for more than just controlling access. Well, in this case, we're going to use ACLs to determine what IP addresses can actually get a dynamic NAT address. Now, this is not the port address translation or the overloading that we talked about where multiple internal hosts can use the same external IP address. We'll cover that in the next lab. So I've backed out all of our configurations on the NAT router except for the IPNAT inside and the IPNAT outside. I figured there was really no point in showing you those commands again. And so just as proof, I'll do show, run, and do include NAT. And the only commands we have that have the word NAT in them are IPNAT outside, IPNAT inside. Prove there's nothing up my sleeve, I'll go over to the client and I'll ping 100.50.25.1. And you'll notice that all of my requests time out because I no longer have that static translation in the NAT router. Or more accurately, the traffic gets to the NAT router, but it says the destination is 192.168.1.1, and I've purposely not put a static route or a default route in my internet router, so it doesn't know how to get back to that network. If I put a default route in there, then obviously it would work because this is just a router in the middle of this, but the internet doesn't have a route back into your internal network, so neither should my internet, all one router of it. So the first thing we're going to do is define a pool of addresses that can be used on our outside interface to do this dynamic NAT. Now, normally what IP addresses you can use would be dictated by your internet provider. In our case, since this is all a closed network, I can use whatever addresses I want. So I'm going to use 100.50.25.100 through 105, which allows us 6 IP addresses. So I'll go to the NAT router and go into the config mode. We're going to do IPNAT pool. We have to give the pool a name. In this case, we'll do public IPs. And we're going to start it at IP address 100.50.25.100. And we're going to end it at 100.50.25.105. And we're required to specify either the net mask or the prefix length for our outside interface. In this case, I'll do prefix length 24, since this is a Class C network mask that I'm using on my internet segment. After that, we can specify the type if we like, match host or rotary. Match host essentially means if you have an inside IP address of 192.168.1.10, it's going to try to NAT out using an IP address of 100.50.25.10, which makes for a pretty logical way of doing your dynamic NATs. The default is rotary, which is you take the next available translation that's not currently in use and you assign that to the pool. In this case, we're not going to specify a type. We'll hit enter. So now we have a range of 6 public IPs that we can use for our address translations. Next, we're going to configure an access control list that defines what IPs can actually get out to the internet. So we're going to do IP access list. Since all we're filtering on is the source address, all we have to use is a standard access list. Now again, if you wanted to get very, very specific about what hosts are allowed out to what services on the internet, you can use an extended one. But in our case, we'll just do a standard. And we'll give it an access list number of 50. For this access list, we're essentially going to permit everything inside of our network because it's all just one Class C network. So we'll do 10 permit the address of 192.168. Let's make sure it's a .1. 192.168.1.0 with the wildcard bits of 0.0.0.255. And remember, your wildcard bits are the inverse of the subnet mask. You can log matches against this entry in the local system log if you want. That's what that log keyword does. We're not going to do that. So now we've got our access list set up. Since we're not using it for filtering, we don't have to have a permit all at the bottom of it. If we did have a permit all, then it would allow anything through. And in fact, that would be a valid way of NATing anything that's on the inside network out through this NAT pool. So I'm going to pause the video here, and we're going to put this access control list and this NAT pool together and verify it in the next video.